Okay, my name is Brendan, and I'm here to tell you that concrete is sexy. Yep. So concrete is everywhere. We're literally surrounded by it, and it's the second most used resource in the world. Any guesses to what's the first? Water. Yeah. So second to water. And it kind of cheats because water's part of concrete too. So, okay, so where does it go? So concrete, as you can see, goes by far into the floors. Kind of a who would have guessed type thing. Maybe you would have guessed it would be mostly in the columns. Maybe these columns. These are some pretty big ones around here. But a lot of it, 2/3 of it goes into the floors of the structure. So what do we do? Well, we're focused on really the short-term life of concrete, or the early life, I really should say, of concrete. And that means we're focused on the curing of concrete and the drying of concrete. And they're two independent processes. So the curing of concrete is a short-term process. It lasts 28 days, it's dictated by code, and it's the process of the concrete getting hard. So it's independent of the drying of concrete. So the drying of concrete, believe it or not, has nothing, well, contributes to curing, but again, it's totally independent. And it's a long-term process, so you can conclude once concrete has cured and it's hard, it's actually still really wet. And that's actually problematic for contractors. So the drying also is very unpredictable. It can last anywhere really from a month to 2 months on the short end, to the long end, something like 18 months. So the implication there for contractors is that they have a difficult time planning for that, because if their concrete is actually too wet, it's very expensive. Expensive to the tune of about $5 a square foot. Okay, so what are we doing? So we have a sensor that's about 2 inches by 1 inch. If you haven't seen it, come on down afterwards. And it gets zip tied to rebar, and it gets embedded in the concrete. So we're never getting it back. As I told many of you, we joke that we might as well send it to the moon, because it just better work. So it's buried into the concrete, and it measures two things: temperature and humidity. And then there's also some testing that we do ahead of time that allows us to tell the real-time strength of the concrete. So combined with knowing the physical properties of concrete, we could say that, hey, if you poured yesterday, right now your concrete's 1,615 psi. And that allows contractors really to move to the next step. It allows them what it's all about is moving faster and saving money. So what does that really mean in practical terms on a job site? So again, speed, taking forms down faster, telling the contractors when they can come back. Cold weather, so concrete is, you think about it, it's just this miracle material, it just works, etc. Well, actually, it only works in it works best in this Goldilocks type range of temperatures. So above 40 degrees, less than really 160 degrees. And in cold weather, specifically around here, it's very, very expensive to cure concrete. And what that means is you could be spending upwards of thousands of dollars a day just on fuel costs to keep the concrete warm so it doesn't freeze before it's gotten hard enough. Moisture, so flooring problems. So if the concrete is still too wet, it takes a long time again for it to dry out, then the problem is that the flooring will fail. Catastrophic disasters, something obviously very important to monitor, something that we do as well. And then just conflict resolution. You've probably heard about construction, a lot of litigation. That's where we can come in. And then just kind of one last parting shot where we fit in. I really see what we're doing as part of this big wave of technology that's coming into the construction world, and we're part of the connected job site. So this is actually a graphic made by Autodesk. Maybe Nicole can tell me when it was sent, but it shows the job sites of the future are going to be automated, and we're we're really interested in helping to automate those job sites. Any questions? Yeah.
Have you calculated how much time savings could possibly be made?
Yeah, yes, the question is how much time savings can be possibly made. And if you were pouring a complicated piece in a building around here, the engineer might say to you, hey, leave the forms up for 7 days. Well, in fact, we could probably prove that it's only going to take 3 to 4 days for it to cure. So if you multiply that savings over say, just a 10-story building, you're talking about a month of time that will be saved. Other questions? Thank you.